Hi, this is Mark Espenheid, and I'm going to step us through an example of a geometric series. So let's say we have a geometric sequence, and that geometric sequence I'm going to start with the number 2, and each time I'm going to multiply by 3, so we get 2, 6, 18, 54, and 162. And in this example, I've set n equals 1, n equals 2 gives me 6, n equals 3 gives me 18, n equals 4 gives me 54, and n equals 5 gives me 162. Okay, I've got 5 terms here. The 2, 6, 18, 54, and 162. Okay, so there's my geometric sequence. I have g1 equals 2, and I know the common ratio, for example, is going to be equal to 6 divided by 2, which is the same thing as 18 divided by 6, which is 3. Should be the same for any of those that I try to divide, where I have one term divided by the previous term. Okay, let's take a look at this for a geometric series. In a geometric series, we're going to add this up. So let's define this as S5. So S tells me I've got a summation going on, and 5 I'm adding up 1, 2, 3, 4, 5 terms. So S5 here is going to equal 2 plus 6 plus 18 plus 54 plus 162. Now I could take this into a calculator and add these all up, but we're going to see if we can't do this in a little bit more elegant fashion. I'm going to take this, I'm going to multiply the entire thing by 3. That's the common ratio. And I get 3s5, that's going to equal 6 plus 18 plus 54 plus 162 plus 486. And what you'll see at this point is that these all line up very nicely for the most part. The 6 lines up with the 6, the 18, the 18, the 54, the 54, the 162, and the 162. And I can set these up so that they line up very, very nicely here. I can redraw this just a little bit. I can do 3s5 equals 6 plus 18 plus 54 plus 162 plus 486. And I'm going to say down here, I'm going to repeat my original S5. And this is going to equal, and I'm going to rewrite this a little bit. I'm going to do this as 6 plus 18 plus 54 plus 162 plus 2. Now, I've put these out of order, but since I don't care about the sequence, sorry, that's a bad word. Since I don't care about the order in terms of addition, I can do that. Now, what we can see here is that these portions all match up. Okay? And if I subtract, I can get to the point here where on the left side of this equation, I get 3s5 minus s5. Now, of course, 6 minus 6 is 0, 18 minus 18 is 0, 54 minus 54 is 0, 162 minus 162 is 0. All of this stuff inside of the blue brackets that I've drawn in is 0, and we're just left with the 486 minus 2. And then at this point on the left side of the equation, I can say that 3s5 minus s5 is just giving me 2 times s5. And then on the right-hand side of the equation, we get 484. And if I divide both sides by 2, I finish up with a statement that s5 equals 242. And I know that if I add up 2 plus 6 plus 18 plus 54 plus 162, that is going to give me 242. So there's one example with actual numbers, and I'm going to come back here in a second and derive an equation in terms of variables.